Hello dear students, welcome to revision series of grade 10. Students, through these videos, I will be discussing all the NCERT questions and also board questions. Students, this is a very humble effort to help you out in preparing for the examinations. Okay, students, many a times we may be knowing the answer for any question, but in the examination paper, what happens is when we present the answer, we make so many mistakes. It may be the presentation part, or it may be the word choice. Okay, so there are so many aspects when we are presenting a particular answer in the examination, and that matters a lot. So I hope you will be able to get all the tips, okay, regarding presenting the answer along with the concept through these revision series videos. Okay, so in each and every question, when I am explaining the question, I will be giving you the tips about how to present the answer. Alright, students, I am very sure with the grace of God and your determination, you will be able to do very well in your examination. Okay, so from my side, whatever support is possible, I am ready to give. Okay, yes students, so without any further delay, let us start. So I will be starting with the chapter Chemical Reactions and Equations. Okay, so first of all, we will do the NCERT in-text questions. Okay, well, the first question. So this is a very simple question, that is, why should magnesium ribbon be cleaned before burning in air? Okay, I hope all of you are aware that when magnesium ribbon is held to the flame, so it catches a dazzling, it starts burning with the dazzling white flame. Okay, but what happens is, if you just hold the magnesium ribbon, it won't catch fire. So that's why they are asking, why should it be cleaned before you hold it to the flame? Normally when magnesium ribbon is exposed to air, it will develop a layer on top of it, that is magnesium oxide layer. And this magnesium oxide layer is really stable. Okay, so since it is stable, even if you hold the ribbon to the flame, it won't catch fire. Okay, so what is important here? We should remove that coating or layer of magnesium oxide. And how do we remove that? Using sandpaper. So if you rub the magnesium ribbon with the sandpaper, so you will be able to remove this oxide layer and magnesium will be exposed to the flame. Okay, otherwise it's magnesium oxide which is coming in contact with flame. So we remove it using sandpaper and then we hold it to the flame. Alright, so how to present the answer? So you can write it this way. Magnesium ribbon, when exposed to air, develops a coating of magnesium oxide, which is a stable compound. So therefore, it should be cleaned before burning in air. Okay, that's all. So sometimes there may be a term, it should be rubbed with the sandpaper. That means that's how we are going to clean it, using sandpaper. Okay, so that term you can see sometimes. Alright, so this is how you should present this answer. Very simple. Okay, coming to the second question. Balance the following. So we are going to do many balancing questions in this chapter. So very simple question is here. Hydrogen with chlorine giving hydrogen chloride. So a word equation is given here. We are supposed to convert it into formulas and write the chemical equation, a balanced one. Alright. So hydrogen, students, here always will have a confusion whether to write it as H2 or you should write it as H. Students, when hydrogen exists as a diatomic gas, always remember. So please don't write it as H, it is H2. Okay, and you know it's a gas. Similarly, chlorine also. It's not Cl, it is Cl2. It exists as a diatomic gas. So you may be wondering, so how do we know whether it is H or H2? Students, these gases, H2, O2, N2, or maybe halogens like chlorine, bromine, iodine, fluorine. So they all exist as diatomic molecules. Okay, so always remember to write H2 or Cl2 or Br2 like that. Clear? Okay. So after writing this, now this is also in the gaseous form. Okay. So H2 and Cl2, what it gives? Hydrogen chloride, that is HCl. Okay. Even hydrogen chloride is a gas. Now let us balance it. Very simple. Hydrogen is also 2, chlorine is also 2. So we will write 2 over here. Okay. Please don't write 2 over here because we are not going to change the formula of hydrogen chloride. Hydrogen chloride is HCl. Okay, good. Coming to the next question now. Barium chloride, aluminium sulfate, giving barium sulfate and aluminium chloride. Okay, simple. What is this barium chloride? BaCl2. Now if you have problem with the formula writing, students, Ba is 2 plus, okay, and then for Cl, the charge is -1, okay, and now when we cross the valencies, so what you will get is BaCl2, okay. Now similarly aluminium sulfate, so Al and SO4, students, Al is 3 plus, SO4 is 2 minus, so we write the 3 here and this 2 over here, so Al2SO4 thrice will be the formula. Alright, now I will remove this because this we need not write. Okay, so what we will get here? BaSO4, that is barium sulfate. Once again, Ba is 2 plus, that I told you here. SO4 is 2 minus. So both are 2. So the simplified formula is BaSO4, okay, plus aluminium chloride. So it is AlCl3. Why? Because Al is 3 plus here and Cl is in -1 state. Alright, so AlCl3. Now, let me tell you certain things here. One is, what type of a reaction is this? Okay, you don't have to mention it, but just for your knowledge. So here, this is a double displacement reaction. Okay, and please remember this is an ionic equation. That means ions are going to be exchanged over here. So it takes place in which medium? That's very important. So it takes place in aqueous medium. So we mention it aqueous because we are going to take aqueous solution of barium chloride and we will mix it with aqueous solution of aluminium sulfate. Alright, so two solids cannot react here. Please remember that. So we get a precipitate of barium sulfate, which is a white precipitate. So I will write it as solid. Okay, and then aluminium chloride, once again it will be in the dissolved state. So it is aqueous. Okay, now we will balance it. How to balance? Very simple. Students, as you can see here, there is 3 chlorine here and 2 chlorine here. So how can we make this 3 and 2? Okay, so we can actually start from anywhere and then I will tell you it is like a chain, we can do it. How? So how to make 3 and 2 equal? That is by this you can multiply by 3. So 3 into 2 will be 6 and this you can multiply by 2. Okay, so both the side becomes 6. Look at this. So I am writing 3 over here and I am writing 2 over here. So chlorine became 6 and here also chlorine became 6. Okay, now barium is 3. Okay, barium is 3. Let me write it as 3. Now I will cross check with sulfate. Sulfate also, here sulfur 3 and oxygen 12. Okay, or as a whole sulfate I can take, okay, 3. Fine. Can you see here 3 sulfate? It's balanced already. Okay, what about aluminium? That is also balanced. Okay, so I started from this chlorine, the one with maximum number of atoms. Okay, chlorine, I made it equal because it's 3 on one side and 2 on the other side. So I balanced it and then I went to the next immediate cation here, this one, barium. Okay, and then after barium I went for sulfate and finally aluminium. So it goes like a chain. Okay, I hope it's clear. Okay, so this is how we balance it. Next one, sodium with water giving sodium hydroxide and hydrogen. Okay, sodium, Na. Students, here you will get a doubt. Should I write it as Na or is it say Na2 or something? No, it is a metal, right? So we'll be writing as monoatomic. So like Na. So it represents the metallic sodium. If it is aluminium, you will write it as Al. Okay. For example, here, if it is this reaction, you would write it as Mg plus O2 giving MgO. Okay. So sodium plus water, that is H2O. Fine. So sodium is a metal, so it is solid. Water is liquid. So what we get here is sodium hydroxide. What is it? NaOH. Okay. Na plus OH minus. Now sodium hydroxide in the dissolved state, so aqueous plus hydrogen. Students, once again the same rule applies here. So it's a diatomic gas, so H2. It's a gas. Okay, you can write upward arrow mark here. Okay, let us see now how to balance it. 2 here and 3 hydrogen on the other side. Product side we have 3 hydrogen and reactant side we have 2. So how do we balance it? So let us try to make it even number, then only it is easy for us. So 2, and if I put 2 here, so 2 hydrogen and 2 hydrogen becomes 4, right? So why I made it even number? Odd number would be difficult. What number you will put for balancing? So I made this hydrogen even number first, that is 2 into 2, 4. Okay. Now this side it became 4. What about oxygen? It's 2. Look here, 2. Okay. Now here also it is 2. What about sodium? Sodium is 2. So I need to put 2 over here. Please don't write 2 at the bottom. That's not correct. Alright. So this is the balancing of these 3 equations. I hope you are clear with these questions.